Session 1.3 Collecting Sample Data. If sample data are collected in an inappropriate way, the data may be useless. We obtain data from two sources. The first one we call observational study. We observe and measure specific characteristics, but we can't attempt to modify the subject being studied. So observational study, we only can observe the subject. For example, determine whether smoking increases the risk of heart attack. A group of smokers and a group of non-smokers are observed for several years. We only do observation, but they were not given any treatment. So we have a two group in here. First group, this is going to be smokers. Another group, that will be the non-smokers. And then we only observe for several years. We can't give them any treatment for these two group of the smokers, and a couple years later we're gonna compare for their health. So we call this as observational study. Second one, experiment. We apply some treatment and then process to observe its effect on the subject. Subjects in experiment are called experimental units. For example, randomly assign 50 of the 100 women to the smoking treatment and the other 50 to the no smoking treatment. Okay, experiment. So we have a two group of the people. We randomly assign 50 women in this group. So 50 women here and 50 women here. And for the first group, we're gonna give them the smoking treatment. Okay, smoking treatment. And another group here, we're gonna give them no smoking treatment. And we're gonna compare the result for several years. And for the no smoking treatment here, we also say this is gonna be the control group. Set up the control group is just for you guys to compare with the one with the smoking treatment for this one. And we call this is gonna be the experiment. Okay, sampling method. We're gonna learn 5 different sampling methods. First one, simple random sample. A sample of n subject is selected in such a way that every possible sample of the same size n has the same chance of being chosen. This is called simple random sample. Make sure highlight the last sentence. They have the same chance of being chosen. For example, okay, imagine that's a 10,000 lottery tickets and I want to pick 5 winners from there. So what is the fairest way to do? I will put that 10,000 tickets in a jar and mix them. And then I'm gonna draw 5 tickets one by one. And we call this as the simple random sample. Because these 10,000 lottery tickets, they have the same chance of being chosen. Give you guys another example. Let's say I have a $100 gift card and I want to give it to the students to this college. Since you guys taking my class, I only want to give it to you guys. So what I'm gonna do, I'm gonna look at my class roster and I randomly pick one student from my class. Think about it, is it a simple random sample? No, right? Because not all the students in this college have the same chance being picked. So this is not the simple random sample. Okay, keep in mind, simple random sample, everyone have the same chance of being chosen. This is the first sampling method. Second one, systematic sampling. Sampling in which data is obtained by selecting every cave objects. The cave here, this is talking about like the second one, third one, or fourth one, okay? It depends on how many samples you want to get. So look at this example here. walking alongside in line of the people and choosing every third one. So you could see on here, I'm gonna pick every third one to be my sample. 1, 2, 3, this is my sample. 1, 2, 3, this is my sample. 1, 2, 3, this is gonna be my sample. You can get like every third one, every fifth one, or every hundredth one. It depends on your sample size also. This is called systematic sampling. Convenience sampling. We simply use the results that are very easy to get. So let me explain this example. There are 1000 concrete boards in here, and each board is about like weighing like 50 pounds. It's really heavy. And the engineer, he wants to investigate the strength of the concrete boards. And he wants to pick the sample 10 of them. N equal to 10 means the sample size, he wants to take 10 of them. So think about it. Which sampling methods do you guys want to choose? You could have the first one called simple random sample. Okay, simple random sample. So how can we perform the simple random sampling? The engineer, he can use a paper, write down the number, and then put it on each concrete boards here. So let's say this is 1, this is 2, this is 3, this is 4, 5, 6, 7, 8, 9, 10, keep going. Okay, and then he gonna use a drum to mix the number really, really well, and then try to pick 10 of them. But think about it, is it a good random sample method? Let's say he picked like, this is gonna be, let's say this is a 14. Let's say he picked like 14. So what he want to do, he need to move out all these concrete boards to get out of these one, the 14th one, and then to investigate it. Do you guys want to perform this sampling method? No, right? Because the concrete boards is really heavy, you don't want to move them out to investigate the bottom one. Okay, so this is not a good method. Okay, how about the second one, the systematic sampling? So let's say we need 10 of them, and we do have a 1000. So we could choose every 10th one, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm gonna move out this board and then keep it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, okay, let's say this one. So you're gonna keep counting with using the systematic sampling. Is it a good sampling method? No, right? Because again, if I want to take out this one, I have to move out on the top of the concrete boards. Again, it's really heavy. So this is not a good method either. So what can you do? You're gonna use the number 3 method, convenience sampling. So this just means just pick whatever easy to get. So you could see, okay, I'm gonna pick these 10 boards from here. Because this is on the top and easy to get it. And I just want to investigate these 10 concrete boards. But what's wrong with this sampling method? Convenience sampling method, we consider this as a bias sampling. You only take something easy to get. You never investigate other concrete boards from here. Okay, they may just put the best concrete boards from here on the top, and then other than that may not be the good, has this 10 of them. So if we have a chance, we don't want to use the convenience sampling method. But sometimes, just like this example, you may not have another good method to choose. You may want to choose this one. Number 4, stratified sampling. Sampling in which the population is divided into groups according to some characteristic. Then we draw a sample from each subgroup. Just think about it. This is my population. And then I'm gonna divide it into subgroups according to some characteristic. You can according to their age, according to the gender. It depends on what you guys looking for. After you divide it into subgroups, okay, that's a 1, 2, 3, 4, 5, 6 subgroup. I'll be using the simple random sample to pick it from each subgroup. So let's say for this group, I'm gonna close my eyes, I'm gonna pick this and this. So these two guys will be my sample. And another subgroup, I'm gonna close my eyes, I'm gonna pick these two. So these two guys will be my sample. I will use the simple random sample to pick from each subgroup. And for this example, since each subgroup, they do have the same number of the people, okay? Each subgroup, we do have 6 people in here. So that's why I'm going to take 2 people from each subgroup. And it also depends on your sample size. So here, my sample size is going to be 12 people. And we call this as a stratified sampling. Let me give you guys one more example. How many students like online learning class in UC Davis? So we're going to look at the UC Davis students and we consider this is my population. Now I will divide it into subgroups. I'm going to divide it by their freshmen, sophomore, juniors, and seniors. Okay, so I do have 4 subgroups in here. And then I find out the number of the freshmen in UC Davis is about 6,264. I have this number for sophomore, juniors, and also the seniors. So the total number of the students, that will be 21,239. And for the sample size, I'm looking for 1,000. So you can see, this time I have a different number for each subgroup. And I want to pick 1,000. So what I'm gonna do, I'll be using this formula. I'll be use the number of the freshmen, 6,264, divided by the total number of the students. And then I'm gonna multiply my sample size, which is gonna be 1,000. 1 to the whole number. So means I'm gonna use the simple random sample to pick 295 students from the freshmen. Okay, I want you guys try to calculate how many students we need to pick from the sophomore, juniors, and the seniors. Okay, for the sophomore, number of the students in the sophomore divided by the total, multiply the sample size. And then I'm gonna get 182 students. Juniors, you should get 262. Senior, you're gonna get 261. After that, we need to double check if the sample size is gonna be equal to 1,000. So I'm gonna add up these 4 numbers. You could find it out, it's gonna be equal to 1,000. This is the sample size we are looking for. Okay, so this is another example for the stratified sampling. And if you have a different number in each subgroup, cluster sampling. Sampling in which the population is divided into groups. Some of these groups are randomly selected, and then all of the elements in those groups are selected. Highlight this one. All of the elements in those groups are selected. This is really similar to the stratified sampling. You're gonna divide it into subgroups according to some characteristic. After that, you're gonna close your eyes and just pick, okay, and let me pick this group. So all the member in this subgroup will be my sampling. And then close my eyes again and I'm gonna pick here. Okay, all the members on this subgroup will be my sampling. Okay, don't mess up with the stratified. Stratified sampling, after you divide it into subgroup, you're gonna pick some number of the people in each subgroup. And for the cluster sampling, after you divide it into subgroup, you're gonna choose all the members in that subgroup. This is called cluster sampling. Okay, I want you guys try to do it by yourself. Write it down which sampling method. Okay, number one, choose every 10th person in the list of member in the population. Every 10th person, so this is gonna be systematic. Number two, creating a group based on age and drawing 2 people from each group for a sample. So first, you're gonna divide it into subgroup, either stratified or cluster. And then you're gonna join 2 people from each group. So every subgroup, you're gonna pick 2 people. So this is stratified. Number three, creating a list of churches in the United States. Choose a sample of church and then obtain the list of all members from those churches. So again, you're gonna create into subgroup, and then you're gonna randomly pick all members from those churches. So this is gonna be cluster. Number four, at the shopping mall, approach people passing by to ask them how often they shop at the mall. Think about it, if this is a convenience sampling method or simple random sample. This is going to be convenience. Remember, the simple random means all the subjects have the same chance being picked. At the shopping mall, you just approach people passing by, okay? So not all the people have the same chance being picked. So this is a convenience. Number five, a completely random method is used to select 75 students. Each undergrad student in the 4th semester has the same probability of being chosen at any stage of the sampling process. So this is going to be the simple random, right? Every students in the 4th semester, they have the same chance being picked. Okay, at the beginning, we talk about the observational studies, and there are 3 types of observational study. First one, retrospective study. Data are collected from a past time period by going back in time. This is talking about the past time period. For example, a research company used a device to record the viewing habits of about 15,000 households, and the data collected over the past 6 years will be used to determine whether the proportion of a household turned to a particular sports program increase. So you could see we only do observation. We didn't modify the subject. And the data will be collected in the past 6 years. So we call this is a retrospective study. Second one, cross-sectional study. Data are observed, measured, and collected at one point in time, not over a period of time. So similar example, just the data collected today, okay, at that time, cross-sectional study. So think about it, there's a 3 types of observational study. One is from the past, one is today, at that time. Think about it, what's the last one? The last one called prospective study. Data collect in the future. So same example, we just the data collect over the next 19 years, collect in the future. That will be the prospective study. Okay, starting from here, this is all about like the definition. First one, randomized experiment is a study in which the investigator assigns the treatment to the experimental unit at random. A randoming separate into 2 groups of the children, and this is gonna be 200,745 children. And this group, we do have a 201,229 children. Okay, and for this group of the children, we're gonna give them a treatment. Okay, they're gonna receive the start vaccine. And another group of the children, they only receive the placebo. Okay, placebo means looks like a drug but does no medical effect. And we call this as a randomized experiment. Okay, we talk about this one at the beginning. This is the experiment, and remember how to call this group? This is called the control group. The control group is used to compare with the experimental group in here. Okay, one more time. This setup, we call this as a randomized experiment. Okay, and then they say blinding. Blinding is in effect when the subject doesn't know whether he or she is receiving a treatment. So blinding means whenever they give you the shot vaccine or placebo, you never let the subject knows which one they're gonna receive it. Okay, you never tell the subject you are in the control group or you are in the experimental group. This is called blinding effect. Second one, an experiment is a double blind if neither the investigator nor the subjects know who has been assigned to which treatment. Doctor and children both did not know who gave the injection and whether they were getting the shot vaccine or placebo. So double blind experiment means when you guys set up the experiment, even though the doctor, the nurse, and the subject, they don't know who gonna receive the shot vaccine, who gonna receive the placebo. This is called the double-blind experiment. Okay, randomized board experiment. A board is a group of subjects that are similar, but boards differ in ways that may affect the outcome of the experiment. For example, how effective a certain adult flu vaccine is. A treatment group vaccine and a control group, no vaccine will be used. We have to consider the age of participants. People have a different age, have a difference in exposure to the food, immune systems. Age should be the blocking variable. So how can we set up this randomized board experiment? We're gonna consider the age. So what we're gonna do? So age, that will be the factor we have to consider. So I'm gonna divide it into 3 subgroups. So the first group I will consider from 20 to 40. Second group, that will be from 41 to 60. The last one, that will be from 61 to 80. Okay, divided into 3 subgroups. For each subgroups, I'm gonna divide it into 2 groups. The first one here, they're gonna receive the flu vaccine. And another group, they're gonna receive the placebo. Same idea from the second one, they're gonna get the flu vaccine, and another group get the placebo. This one also, we're gonna get the flu vaccine and also the placebo from this group. Now we could compare for it. Under the age from 20 to 40, you could compare the vaccine and with the placebo. And again, the placebo here, this is gonna be the control group. And 41 to 60 also compare with this group and also compare with this two. And also we could compare the people in different age to receive the vaccine. We could compare here to here and to here. And we call this as randomized board experiment. Randomized board design is pretty similar to the stratified sampling. Remember what is a stratified sampling? We're gonna divide it into subgroup and pick some sample from each subgroup. Only difference is stratified sampling, we are using the sample for the survey, and randomized board experiment, this is used for the experiment. Sampling error occurs when the sample has been selected with a random method, but there's a discrepancy between a sample result and the true population result. For example, the difference between a population mean and a sample means is sampling error. Sampling error occurs because a portion and not the entire population is surveyed. For example, your sample size may be too small, it can't represent the population. Non-sampling error is the result of human error, including such factors as wrong data entries, computing errors, questions with biased wording, false data provided by respondents. Remember in the section 1.1 we talked about it, sometimes people refuse to answer the survey questions and make your result dramatically different. Or you may have a wrong data entries. You may want to put 52, but you're gonna put 25 on it. And we call this as non-sampling error. Last one, non-random sampling error is the result of using a sampling method that is not random, such as using convenience sample or a voluntary response sample. Remember the convenience sample and the voluntary response sample? Both of them, we call this is the biased sampling method. If you use the biased sampling method, you may get a different result for it. So we call this is non-random sampling error. That's it for the session 1.3.